Okay, so I had to kind of abruptly stop that last video because I realized as we were working through it that we were not getting what we were supposed to be getting. And I wanted to stop and just make sure I could figure out why that was happening. And I figured it out pretty quickly. It's that there was a typo in my notes. So we were destined to fail from the beginning. And that's okay. So the problem was that my integral here in our solution was e to the negative t squared. It was supposed to be e to the positive t squared. That was the problem. So I very sloppily changed that minus into a plus, and I also did that for everywhere where that integral showed up in my work down here. When that happens, the key thing that changes is that this step right here, where we perform the product rule on this term, this second guy right here, when we differentiate it, should come out to e to the positive x squared instead of e to the negative x squared. We're still multiplying it by e to the negative x squared because that came from this guy. That product is what gives us the 1 that we wanted. So I changed that to a 1 here, and that's giving us the correct solution. Okay? All right. Sorry about that. So you're going to notice that I make little mistakes here and there, and sometimes they're just careless mistakes. Other times they are typos in my notes, and I kind of just run with it. I may do that again in the future, stop a video to see what's going on, and then come back and say, oh, okay, here's the mistake. If I wanted to try and play it off a little bit, I'm gonna say that I intentionally leave those mistakes in the videos and then show you myself correcting them, because that is really part of the learning process, right? We make mistakes, we learn from them, we move on. Anyways, trying to save face there a little bit. The last thing that we need to talk about in this section is systems of ordinary differential equations. And you're already familiar with systems of equations from algebra. These are similar. In a system of ordinary differential equations, what we're looking at are two or more functions of the same independent variable. In my example here, I'm looking at two functions, x and y, and each of these are functions of t. T is the independent variable, and it's important that both functions have the same independent variable in these systems. So a system of two ODEs might look something like this. dx dt equals some function of t, x, and y. dy dt equals some function of t, x, and y. In this case, these are first-order equations, but they could have higher-order derivatives in them as well. In fact, the example that we're going to look at down here has equations that are second-order equations. So let's give this a shot. Down here, I am given a pair of functions, and I'm asked to verify that they form a solution to this system of differential equations. Now notice we need a pair of functions because we have two functions showing up in the system, x and y, and it requires both of them to work simultaneously in both solutions, or both equations, in order to be a solution. So it looks like what I need are second derivatives of my x and my y. Let's find those. dx dt, what is that? Okay, well I have cosine of 2t plus sine of 2t plus 1/5 e to the t, so that's going to give me negative 2 sine of 2t plus 2 cosine of 2t plus 1/5 e to the t. Now my second derivative, because that's the one that I actually need, is going to be negative 4 cosine of 2t minus 4 sine of 2t plus 1/5 e to the t. Okay, let's do y now. What is dy dt? Well, I have y up here. That's going to equal negative, actually this will be positive 2 sine of 2t minus 2 cosine of 2t minus 1/5 e to the t. Second derivative equals, this will be 4 cosine of 2t plus 4 sine of 2t minus 1/5 e to the t. Okay? What I'm going to do is make substitutions on the left and right hand side of this equation, and then do the same thing in the second equation. And then just try and see that they turn out to be identities. In fact, let's make life a little bit easier on ourselves. Let's simply plug y into this right-hand side and then simplify it down and see if the result matches what we got for the second derivative of x with respect to t. So starting here, 4y plus e to the t. 4y plus e to the t looks like 4 times y was given up here, negative cosine of 2t minus sine of 2t minus 1/5 e to the t. And then this is plus e to the t here. Okay? So multiplying the 4 in here, I'm going to get negative 4 cosine of 2t minus 4 sine of 2t. This will become minus 4/5 e to the t plus e to the t. Adding these two common terms, I get negative 4 cosine of 2t minus 4 sine of 2t plus 1/5 e to the t. And if you notice, that's exactly what we had for our second derivative up there. Okay? Check. We verified that first equation. I'm going to let you do the second equation because the work is so similar it's not worth the time, really. So I'm going to say verify second equation yourself. Okay? But you should be able to substitute the function that we're given for x into here, compare it to the second derivative of y with respect to t that we got here, and see that they are the same thing. Okay? That's going to wrap up section 1.1.